Okay, let's get started. So many of us have visual problems, right? We can't see far, and as you get older, I'm luckily not there yet, but you get difficulty seeing what? Close. Okay? And the reason that these changes happen is the actual length of the eye will change over time. Okay? With what's called myopia, which is nearsighted. When somebody says they are nearsighted, it means that they could see, just like me, if I take my glasses off, I could read just fine, but I can't see far. Okay, that's myopic, is the actual term for it, the clinical term for it. Okay? So nearsighted. So where did I skip a slide? I did? No. Okay. Okay. So myopia is nearsighted. So you can see, let's look at that picture, okay? So emmetropic is the picture at the top. What that simply means is that is somebody who does not have any visual problems, who has perfect sight, okay? You can see because their length of the eyeball is quote unquote perfect for them, the visual, the waves of photons, the vision comes in, and it'll actually converge right at the back of the retina. Okay, that's what that picture is representing there. So when we get visual stimulus coming into our eye, it's actually, is everybody back from the break? Can you shut that door? Because he might be firing up the cleaning machine. Okay, so when vision or light, let's just say light, comes in and it hits the retina and the lens, it gets bent. If it's in a perfect eye, when it's bent, those light waves will converge at the retina, okay, and give us perfect vision. If somebody is nearsighted like me, so nearsighted means I could see close, but I can't see far when I take off my glasses. You could see that light converges in front of the retina. Okay? So then it'll start to diverge again. It won't give a perfect picture. So the eyeball is too long. People who are hyperopic means that they are farsighted. So this is your grandfather, or if your father is older, okay? When they go to read the newspaper, what do? They start to hold it further and further away, right? Because they can't see close. It's called hyperopia, okay? Or being farsighted. They can see far just fine. Some people get both, but I'm just trying to explain them individually, okay? But they can't see close. They always joke that their leg or their arms are too short, right? Because they can't hold the paper far enough away. And that's when they get those little readers, what people call readers, okay? So I don't really care if you know which lenses correct them. I would never ask you that. But what I do want you to know is people who are myopic, the lens or the eyeball, I'm sorry, is going to be too long. And people who have hyperopia, the eyeball is going to be too short. And you can see in that bottom picture that somebody is going to be hyperopic or farsighted, that the rays of light converge after the eyeball, theoretically, right? Okay, theoretically. So they don't converge on the eyeball. They don't even get close to converging, okay, theoretically until after the eyeball. So we're looking for that perfect combination of getting that light source to the back of the retina. And these obviously can be fixed with different lenses or contact lenses as well. Does that make sense? Do you guys have any questions about that? Now, astigmatism is a whole different subject, and probably some of you in this room have astigmatism. Astigmatism is when there's a deformation. When you think about the cornea and the lens, it should be a pretty smooth half circle. Okay, this same optometrist that I went to that they were trying to stab my eyeball out with that thing to measure glaucoma had a really cool piece of equipment that mapped my cornea. And it looked like a little half circle. And what it did was it mapped where my astigmatism was. So instead of being a nice round area, astigmatism is going to be deformed in that area. okay? So it can affect your vision a little bit. It's not going to be a huge, okay, effector, but they do accommodate for it in your lenses when you get your prescription. So astigmatism is going to be a deformation either in the cornea, or there can be a little deformation in your lens as well. And if the whole premise behind the cornea and the lens is to converge those light rays to the back of the eye, well, if one area is a little deformed, it's not going to converge it as well, is it? Right? So astigmatism. Okay. Rods and cones, we talked about this. So rods are going to be dim light and peripheral vision. And we went over how they are concentrated on the periphery of the eye. Cones are going to be bright light and color. They'll be concentrated on the center of the eye, but we have rods and cones throughout the whole retina. Okay, it's throughout that whole retina. So color blindness is a lack of one or more cones. We actually have that, the test for it up in the lab if you're interested. Is anybody colorblind? Color blindness is a congenital, which means you're what? What does congenital mean? It means you're born with it, okay? Congenital, C-O-N, that's a good word to know. C-O-N-G-E-N-I-T-A-L, con means with, genitals, born with, okay? Gestation, I should probably say, so born with. So congenital. So some people just have a congenital defect in their genes that makes them unable to see certain colors. I dated a guy in college who had this, and so he had his mother, because he was still, in college, organize his clothes. So he knew that, blues were here and greens were here and reds were here and whatever was there. So he knew, what to match together. So color blindness. Visual pathway to the brain, this should all look familiar, right? Optic nerve, optic chiasm, back to the optic tracts. Okay, some fibers go to the thalamus. I didn't go over that in lab. Do you guys remember going over this in lab? This optic, okay? So some fibers go to the thalamus. The rest will go by the optic radiation back to the occipital lobe. And the occipital lobe is going to be the primary lobe for vision, okay? Occipital lobe. Primary visual cortex. And we also send fibers to the superior colliculi. Superior colliculi help that reactive response to a really loud stimulus. Do you remember that reflex that I talked about when we talked about neurology? If somebody came in here and threw a bomb in here, you'd look at it so you would assess the situation, and it's a reflex. That visual reflex, guys, is sensed in what's called the superior colliculi. It's part of the midbrain. Okay, superior colliculi. So optic nerve, chiasm, optic tract. Some fibers go to the thalamus, the rest go to the optic radiation. Some fibers go to that colliculi, then the rest go to the occipital lobe. Okay. Do you need me to draw that out, or does that kind of sort of make sense? You need me to draw it out? Makes sense. Okay. Okay, the ear. So 3 parts of the ear. We talked about the easy parts of the ear. Okay, external, middle, and inner ear. We got that. So, and remember, it's going to deal with hearing and balance. We'll talk about those different parts in this lecture. Internal ear is going to function for both hearing and equilibrium. The whole idea of that external ear, though, is to bring in hearing. Okay? I think that's what that slide is talking about. I uploaded that from the book. It's a little confusing. So the external and middle ear are involved with hearing. The inner ear is what's involved with hearing and balance. Okay? The inner ear is what deals with hearing and balance. So that external and the middle ear has nothing to do with balance. Okay? Has nothing to do with balance. That's what that slide is trying to explain there. Here's a nice little picture. This should all look familiar, okay? The helix is kind of that rounded, raised portion. I don't think we went over that in lab. And then the lobule is going to be the part that dangles down that you would put an earring into, okay? External acoustic or auditory meatus is going to be the opening, okay, through which the beginning of that external canal begins. That external canal then goes to what membrane? Tympanic membrane. Very good. Okay, and then we move into the middle ear. The middle ear is going to contain what? What major structures? Malleus, incus, and stapes, right? Which are going to be the three ear bones. But what else does the middle ear contain or have attached to it? Eustachian tube. Very good. Okay. When we get into the inner ear, what are we in then? When we're talking about the inner ear, we're actually into the what? The what of the skull? Into what? Temporal bone. Very good. Okay, you actually move into that bony part of the skull. Okay. So auricle is that entire outer portion of the ear. It's comprised of the helix, which is the rim, and then the the lobule, I'm sorry, which is the dangling part. External acoustic meatus, auditory canal, we talked about this, okay? Has sebaceous glands and ceruminous glands that actually have a little, as gross as this may sound, scent to them to try to keep bugs out. Gross. But that's part of the reason, because if you get a bug in there, and believe me, it happens. My cousin's a PA in urgent care, and guess what she has to go fishing for? She has to go fishing for bugs. Bugs they like to get in there, okay? So one of the ways that we protect ourselves is by having those ceruminous glands, which create a little waxy, smelly substance, which helps to sort of trap those particles. She had a kid come in who had a cockroach in his ear. Oh, yeah. Oh, yeah, you're going to see. I got some stories from her, believe you me. Some I can share, some I can't. Okay? So, bugs will try to, it's a hole. They like to go into holes. Okay? You guys are going to have nightmares about that one, aren't you? Laying in bed, like whacking at your ears. Tympanic membrane, we know, is between the external and the internal, but that's also going to cause that vacillation or that vibration that's going to start sending the signal of sound in through the three ear bones. Okay? Okay. Now, the tympanic membrane is also important for what? What are people looking at when they look in your ear? What do you think people are looking at? Imagine the anatomy of it. So you look down the canal of the external ear, and what's the next thing that comes along? The tympanic membrane, okay? So why would they want to look in your ear? What are they looking for? Ear infections. If you get a middle ear infection, guess what it's going to do to the tympanic membrane? It's going to make it swell up, okay? It'll actually look swollen. There's something called a cone of light that you look for when you start to look through the ear. If that cone of light is not where it should be, you'll learn about this in clinical, there could be distension of that tympanic membrane. There could be a middle ear infection, okay? So that's an important thing to know, okay? That's an important thing to know. Okay. Middle ear. So this is all pretty much we've gone over, right? There's an oval and a round window. Let me see if I have a little picture of it. But we'll talk about that when we get to it, okay? Middle ear pharyngeotympanic tube, we know this already. It's going to equalize the pressure between the middle ear and the external environment. It opens up into the posterior of the nasal cavity. It helps to drain that middle ear so we don't get what? Infections. In children, they're more horizontal, so they can't drain as well. Okay. Oh my gosh, I didn't start the tape, did I? Or did I? Glad you feel my pain. Let's start it. Okay, we're good. We're taping. Okay, so pharyngeotympanic tube connects middle ear to the nasopharynx. Yeah, I don't want to have to do this again. Thank you very much. I got plenty enough to do. Okay, so that's three small bones. They're actually suspended by little bitty ligaments that helps to hold them in place. Okay, transmit that vibration. I'm going to kind of move through. Little muscles contract. You don't need to know their name, but help to Also hold them in place so we don't have excessive movement if there's excessive sound around us. Okay, so little ligaments and muscles to make them move, but also to help hold them in place. Okay, bony labyrinth. So what this bony labyrinth is, if you can picture the inner ear, there's a little like divvied out place in that bone in which we set those semicircular canals in that cochlea. Okay, so that bony labyrinth is what we have carved out for those structures. Okay, so there's a vestibule, a semicircular canal, and a cochlea. I'm going to show it to you on a picture. Okay, it's filled with what's called perilymph, and perilymph is this little fluid, and that fluid will move and it'll stimulate these little hairs that'll send receptors through the vestibular cochlear nerve, so we can sense that sense of hearing. Okay, so here's that little picture of the inner ear. So this is going to be in the temporal bone, this little picture that they've taken out. We've got the 3 different semicircular canals. Okay, you don't need to know which is what. Okay, that's fine. You don't need to know them. What I want you to know from this picture is that there are 3 semicircular canals, and pretty much they're going to be in every direction, aren't they? They're going to be vertical, they're going to be horizontal, they're going to be at a little bit of a, posterior angle as well. We also have the cochlea. Now the cochlea is going to be where we sense the hearing. Those semicircular canals are going to be where we sense rotational movements of the body and the head. Okay, semicircular canals are going to sense rotational movements of the body and the head. Because we're also going to have linear movements, which I'll explain in just a little bit. Okay. The vestibule, guys, you could see, look at the picture for just a second. Can you guys in class see that okay? Can you see the stapes? Okay, and the stapes is the last little bone of the middle ear that's going to transmit that vibration. Okay. And that stapes sits into what's called the oval window. Okay, so the oval window is going to be this little opening covered by membrane, in the temporal bone, and the stapes will hit it, and it'll send that vibration in. They'll go into the cochlea, and it'll stimulate these little bitty hairs that are in the cochlea. That'll stimulate the nerve that goes to the vestibular cochlear nerve. Okay, so that area that the stapes leads to is called the vestibule. So when you walk into the front part of your house, what's it called? A vestibule. Okay, it's the main entrance to an area. The vestibule of this inner ear is the main entrance, and you could either go left to the semicircular canals on this picture, or you could go right to the cochlea. Okay, so it's just this space. But I want you to look. There's 2 structures called the utricle and the saccule. Okay, the utricle and the saccule are in that vestibule. We're going to talk about those in a couple of slides. Okay, are we good with these structures? Good. Okay, so vestibule, and we're going to talk about it right here. So the saccule and the utricle, guys, are going to sense linear movements. They work together, so when you get in your car and you drive forward, that is a linear movement. When you go to get in the elevator and you go up, that's a linear movement. These 2 structures, the utricle and the saccule, will sense that linear movement through space. So you have to be on something, right? You have to be moved. Even walking forward would be a linear movement as well, okay? So utricle and saccule. The semicircular canals sense, when you tilt your head to the side, when you turn your head, those rotational movements are going to be sensed in the semicircular canals. Are you with me? Okay, so 2 different distinct things. Okay. And those are going to be in the vestibule. I think we've gone through most of this. There are, there's one other thing we talked about. So we talked about those rotational movements. There's actual receptors. If I go back here, you see at the base of each of them is cut out on this picture. Okay, there's little receptors called cristae ampullaris. Those cristae ampullaris are the receptors that'll sense those rotational movements. They're at that beginning part of those semicircular canals, cristae ampullaris. Okay. They're going to be the receptors. Other than that, I think we've talked about most of the semicircular canal stuff. Do you guys have any questions so far? No? Okay. Okay. Excuse me. So cochlea looks like a little snail shell. Okay, extends from the vestibule. We talked about that. There's a little bony pillar in the center called the modiolus. I don't know. You don't need to know that. And it contains the spiral organ of Corti. So inside, so that snail shell is just the shell. It's the housing for the organ of Corti. And inside that organ of Corti is a very complex series of structures that actually help us to hear. Okay. So what I want you to understand, I'm not going to get into all the different parts because I think it's pretty complex, is that there's perilymph, which is that fluid, which will be moved and it'll go across these little hair-like structures in that organ of Corti that will help us to sense hearing. Okay, that's the basic gist of it. So if you go to read this in a book, there's, 10 pages on hearing. There's, the structure takes 2 or 3 pages. The physiology is a lot. We're not getting into that, okay? If you go into a specialty, then you can study it then. I think it's too confusing. Otitis media is a clinical name for middle ear infection, middle ear infection. Seen more in children because of the horizontal canals, but it's also important to get it taken care of. If this is not taken care of properly, it can extend into the bone, okay? So likes to go into these little points behind the ear if it's not taken care of. So otitis media is something that definitely needs to be taken care of. The first step is antibiotics, okay? The next step, some children are just more prone to these chronic middle ear infections. If they keep getting them, they have to put little tubes in their ears. Does anybody know where those tubes go? Does anybody know where those little tubes go? Has anybody ever had them? Where would you put it if you can't drain it? Right, out towards, you want it to go out to the external, right? You want to put a hole in the bone, obviously, right? You'd want it to go into the external ear. So where do they put tubes? What would you cut if you had to let fluid out of the middle ear? Is there somebody out there? Outside? Oh, it's the answer. Someone go away. Where would you cut? Tympanic membrane. They put little tubes in the tympanic membrane. That's kind of important to know. Okay, it's also important to know as a clinician because if they have a problem, and they get the tubes put in, they're going to have a permanent opening in the tympanic membrane. Okay, so they couldn't have their ear flushed, could they? Because that fluid would go into the middle ear. That's an important thing to know. Okay. Middle ear. Ear ossicles are those 3 small bones. We talked about this, right? Yes. Okay. I'm starting to get lost. Vestibule, we did. Semicircular canals, we did. Cochlea, we did. Otitis media, we did. Okay. So physiology of hearing stimulates the organ of Corti. There's these little hairs in there. It goes to the cochlear portion of the vestibular cochlear nerve. Medulla crosses over to the thalamus. You don't need to know that. What I want you to know is that it's going to cross over to the temporal region. Okay, it's going to go to the temporal region. Okay, and it crosses over. So organ of Corti, I do want you to know that there's hairs in the organ of Corti that get deformed. It sends signals to the temporal lobe. Okay. So static equilibrium. We talked about this, okay? This is going to be the saccule and the utricle that we talked about. And it senses those linear changes, horizontal and vertical linear changes, okay? Remember that? We talked about the saccule and the utricle. Dynamic equilibrium are going to be the semicircular canals, those rotatory movements, okay? Those rotatory movements. We talked about this. Cerebellum is going to help to integrate information from the inner ear and respond appropriately. Ugh, excuse me. So it helps to make sure that we're coordinated and we're responsive responding appropriately to coordinating our movements. Okay? Very good. Do you guys have any questions? Excellent. Thank you so much. And I will see you guys later. Let's put another song on from Grace Potter. I love her. Right, we'll see you guys in lab and or next week. Okay? Oh, I gotta stop the tape.